Hi everybody, in this video we're going to be talking about rounding and estimating whole numbers. So again, I'm just going to put the title up the top of the page, and you would also want to add the date in here, or the date that you're working. And again, as you're going through, just a reminder, follow along with how I'm doing my notes. So if I write something down, you probably want to write it down too. You may even want to add to these notes as well. So if you find that there's something else that you want to make a note for yourself that you think you're going to forget later, pause that video, add that note for yourself. And even at the end of the lecture, so sometimes it's good before you start the next video to just pause for a minute or two, read back through your notes, and then go and fill in if you missed something. So if you realize, oh, hey, I missed writing that down, or I'm going to forget this piece of information, make that extra note for yourself so that you don't forget. So we're going to be doing just rounding and estimating in this video. So some quick definitions, or one definition to start. Rounding a whole number means approximating it. So we're giving really just an approximation for that number. And why we round is sometimes it's just easier to work with and maybe easier to understand than a more precise whole number. Usually we round in order to do arithmetic in our head and just kind of give us a rough estimate of what we think the answer may be. So we do often have to round. Okay. So let's talk about rounding here and the rules for rounding. Now, there's different ways to think about rounding, using number lines or different rules. So I'm going to show you how I round, and hopefully that will help as well. All right. So my first step for rounding . And this is for whole numbers. So rounding with decimals is a slightly different, but similar. So my first step is to underline the place value you want to round to. And then you're going to use the number to the right of the underlined number to determine how to round. Okay, so what happens is if the number to the right of the underlined number or digit is 5, 6, 7, 8, or 9, then add 1 to the underlined number. If the number to the right of the underlined number is 0, 1, 2, 3, or 4, then leave the underlined number as is. Now, this first case here is what most people think of as rounding up. And the second case is what most people think of as rounding down, but when we round down, we actually don't decrease anything. We just, or decrease the underlying number. We just leave it alone. So you don't subtract one with it. You're just going to leave it. And then this is specific for whole numbers. You're going to replace all digits to the right of the underlined number with zeros. Okay, so let's do some examples. So let's say I have the number 15,793, and I want to round to the nearest 100. So you do have to know your place values here. You need to go back and take out that place value chart and line up this number here with the place value chart. Definitely go ahead and do that, because you do have to know which number or which digit is in the hundredths position. So the number in the hundredths position is the 7. So I am underlining the place value you want to round to. So that's what I'm doing here. This is how I do it. And then what you do is you use the number to the right, okay? So use the number to the right. So the number to the right is a 9. If the number to the right of the underlined number is a 5, 6, 7, 8, or 9, which this is, then add 1 to the underlined number. So what's going to happen is we're going to round this up from 7. We're going to add 1 and make it an 8. So my value becomes 15 and then 8. And then we replace all digits to the right of the underlined number with 0. So the 9 and the 3 are going to get replaced with zeros. So this is our rounded number to the nearest 100. So we underline whatever place value we're trying to round to. We use the digit to the right to determine if that underlying number should go up or if it should stay. And then anything after the underlying number becomes a 0. And that is specific to whole numbers. We don't usually do that always with decimals. It kind of depends there. So I'm just kind of keeping that in mind. All right, let's do another example. Let's use, how about 20,542 round to the nearest 10. So here I want to round to that tens position. So what I'm going to do is I'm going to underline the tens position. So the tens position is right here. It's the number 4. So I use the number to the right. Okay. Now that 2 on the right is small, right? It's in that first group, or that second group, excuse me, 0, 1, 2, 3, or 4. So we leave the underlined number as is. So my underline right here is going to stay the same because that 2 is in that small group, that 0, 1, 2, 3, or 4. So my answer becomes 20,000. 5, 4 will stay, and any numbers to the right get changed to 0. So the numbers on the left don't change, it's just the numbers to the right. All right, maybe we can do one more example. So here's another example, 248,982, and we're going to round it to the hundreds place. So the place value I'm looking for is the hundreds. My hundreds place would happen to be the 9 here. Now I look to the right, my number is an 8. So if you go back to the page before for your lecture notes and we read 8 is in sort of the big number category, it's going to take the underlying number and bump it up. It's going to add 1. This is going to increase and add 1 to it. Now this one's a little trickier, right? If you try to add 1 to 9, you get 10. And it's like, well, how does that work? So you can do it a few ways, but one way is you can just note that you really are literally adding the number 1 here. So if I add the number 1, I do get 10. And when I carry, that 8 becomes a 9. So well, first 4 digits here, the 2489, we bump it up 1 unit, becomes 2490. The 89 goes to 90. So we can still add the 1, it just is going to have it to involve carrying here. And then now the 2 remaining digits have zeros attached. So I have the 2490, and then I'm going to attach 2 zeros for the 8 and the 2. So my answer here becomes 249,000. Now, the next thing I want to talk about is really an application of rounding, and that's called estimating. So an estimated number is not exact, but an approximation. And it's very similar idea to rounding. Often we use rounding when we're estimating. So we may round the numbers first to get an estimation for our answer. So we don't get an exact answer, but we get an approximate answer. Now, again, this is really most helpful if we're trying to do something in our head, so doing some mental math and things like that. All right, so let's do an example here. So maybe we're going to go ahead and add 571 plus 82. And what we could do is we can find the exact value. And then also maybe we can estimate the sum by rounding to the nearest 10. So let's find the exact value first. So I'm going to take 571 and 82. I'm going to go ahead and add these, and again, lining up my columns here. So I get 3. Here I have 15, carry the 1, and I have 6. So 653. Now, let's say I want to estimate. So the first thing I'm going to do is I'm going to go ahead and round these values. And it does say that we're going to round to the nearest 10 in this case. So here's my tens position. Now my next value is a 1. And if my next value is a 1, then my underlying value will stay the same. So this stays at 570. Here, my next value is a 2, and we have the same rule. If it's anywhere from 0 to 4, then the underlying value is going to stay the same. So for my estimation, I'm going to add 570 and 80. And I get an approximate answer, right? 650 instead of exactly 653. So again, it just tends to be more helpful if we want to kind of quickly check our answers to see if we're on track, right? If these were very different, then I would think that something was wrong. Either I did one of these incorrectly. It's also helpful for us to, again, try to do quickly some mental math. And then the other thing too is you can always estimate in different ways. So some people may want to estimate to the nearest 10, but you could also estimate this to the nearest 100. Right? So maybe I want to add part C here. I'm going to estimate the sum by rounding to the nearest 100. So I could do it that way too. So if I'm looking at 571 and 82. Well, in this case, my hundredths position would be the 5. My next number is a 7, which is in that bigger category, that 5, 6, 7, 8, 9. So it is going to bump that 5 up. 5 becomes a 6, and my other digits become 0. Now here, I don't have a hundredths place, but I do. I just have to put a 0 in, right? So here's my hundredths position. The 8 is in that big category, so it is going to bump this up 1. So 0 becomes a 1, and these values become 0. So when I add these together, I do get an approximate answer of about 700. Now, again, my rounding was a little bit more rough here, right? I wasn't going as detailed as going to the tenths place. I was going out to the hundredths place. So you can see I have a bigger difference, 700 to 653, but it's still in the ballpark, right? If I were to round this answer to the nearest hundredth, I would also get 700. So it's still going to give me a value in the nearest ballpark here, which is good. All right, let's do one last example. So Joni is grocery shopping and has $20 on her. She wants to buy milk for $4.59, bread for $2.99, she's gonna go to the deli, she's gonna get some cheese, and she's gonna buy 1 pound for $4.99. She's gonna buy a small thing of ice cream for $1.29. And she's gonna buy some cookies to go with that ice cream for $2.49. Estimate her cost to see if she has enough money. Now, in this example, we're going to not worry about taxes. Now, it kind of depends on where you are, obviously. In Massachusetts here, there is no tax on food items at a grocery store. There are taxes at restaurants because that's considered a luxury. There are taxes on other items that are not food products, right? If you buy paper towels or toilet paper or things like that, you may have taxes. Again, it all depends on what you're buying. But for these items, there should not be any tax. So we're just going to do just the cost. So let's go ahead and estimate. Now, I didn't tell you how to round here, but I want you to just maybe pause the video for a second and think. If you're out shopping and you're trying to grab items quickly and figure out if you have enough money, then you're probably going to round to the nearest dollar, maybe the nearest half dollar if you're good at math in your head, but you're probably going to round to the nearest dollar. And we're going to do that here. So your nearest dollar is your ones position. So 4, the 2, or the 1, 2. For the next value, so I look at the 5 here. Okay. Now, I know I haven't done decimals yet with you guys, but I think you can handle this, right? If you have that 5, it's going to bump that 4 up 1 unit, and you're going to be left with 5. And then the values on the right just become 0, so $5. Here, that 9 is also going to bump that 2 up 1 unit. So $2.99 is about $3. Again, that 9 is going to bump us up. $4.99 is about $5. Now, a 2 is small, so it's not going to bump anything up. That 1 is going to stay. So $1.29 is about $1. And also, that 4 here is small. It's in the 0 through 4 category, so that 2 is going to stay. So I'm adding up 5 plus 3 plus 5 plus 1 plus 2. So again, I kind of noticed I took a little bit to the decimals here, but I think you guys can handle it. We know how to work with money. So now I just have a number example here. So I have 5 plus 5, which is 10, plus 3 is 13, plus 1 is 14, plus 2 is 16. So I'm getting $16. Now, $16 is below the 20, and it's significantly below. So obviously, if you're rounding, there could be some discrepancy, right? Because you're giving approximate values, you're giving estimates here. But $16 is pretty far below $20. So I would feel really comfortable going to that register with a $20 bill in my hand and not worrying that I'm over the limit. So it does seem that Joni has enough money. Now, if my estimation was $19 and I had a $20 bill in my pocket, I may be a little bit more worried, right? Because some of these values, I know some of them we rounded up, but some of them we rounded down. So what if I'm a little bit off, right? So if you're using estimation, sometimes it works out great. Here, estimating was perfectly fine, $16, because there's plenty of wiggle room for that $20 bill. But if I got something like $19, maybe I'd want to take out my calculator, or I'd want to sit down and actually write out and find out my addition before I got to the register. So sometimes estimating is great and helpful. Other times we may need a more exact answer. So it's really going to depend on the problem.